Welcome back to the Cisco NetAcad CCNA3 Enterprise Networking, Security and Automation lecture series. If you haven't seen my previous lecture series covering CCNA1 and CCNA2, I will leave links in the description for those playlists. I would recommend that you go through the previous CCNA lectures before you move forward with this course. Today, I will cover module number 6, which is NAT for IPv4. The objective of this module is to learn how we can configure NAT services on edge router to provide IPv4 address scalability. I will cover NAT characteristics, types of NAT, NAT advantages and disadvantages, static NAT, dynamic NAT, PAT, and NAT 64. NAT characteristics. IPv4 address space. Networks commonly implemented using private IPv4 addresses as defined in RFC 1918 standard. So remember, networks are commonly implemented using IPv4 addresses but based on the RFC 1918 standard. Private IPv4 addresses cannot be routed over the internet and are used within an organization or site to allow devices to communicate locally. To allow a device with a private IPv4 address to access devices and resources outside of its local network, the private address must be translated to a public address. So the network address translation, or NAT, provides the translation of private addresses to public addresses. And on the right-hand side, we have three classes of IPv4 addresses. We have class A, class B, and class C. And you see the range in the middle under the activity type, the range of IP addresses associated with these classes. In most home routers, you probably have seen the class C, which is the 192, this IP address range, because that is typically the default on D-Link and Cisco and many other IP address schemes built into some of those routers and modems. But however, you may also have come across the other IP addresses listed here. These are like different types of classes associated with the IPv4 RFC 1918 standard. So what is NAT? The primary use of NAT is to conserve public IPv4 addresses. In my previous lectures, I have mentioned numerous times how we are running out of IPv4 addresses that can be routed globally. So the NAT is actually a temporary solution that we use to prevent IPv4 address exhaustion. So NAT allows networks to use private IPv4 addresses internally and translate them to a public address when needed. A NAT router typically operates at the border of a stub network. When a device inside the stub network wants to communicate with a device outside of its network, the packet is forwarded to the border router, which performs the network address translation process, translating the internal private address of the device to a public outside routable address. So the primary purpose of the NAT is to sit right at the edge of that private network and then translate the private IP addresses into a publicly routable IP address. Hence, the NAT stands for Network Address Translation. And these are typically, this is a process typically happens in the router at the edge of your private network. So in small businesses and in homes, this is typically done in the router modem combination devices or on the router at the edge of your network, which is connected to your the internet service provider. So how does the NAT works? So PC1 in this situation on the right hand side, this diagram, wants to communicate with an outside web server with a public address of 209.165.201.1. So the PC1 which is this one, which is not really labeled as PC1, but this is the PC1 connected to router 1, and it wants to communicate to the web server with the IP address 209.165.201.1, which is outside of its private network. So the web server is not within the PC1's private network. So what happened is the PC1 sends a packet address to the web server. Next, the R2, which is this edge router, receives the packet and reads the source IPv4 address to determine if it needs a translation. R2 adds mapping of the local to global address to the NAT table. So it actually gonna get the local IP and then it's gonna map it to the global IP for that NAT table. Then the R2 sends the packet with the translated source address towards the destination. Then it's gonna get forwarded towards the destination of this server. The web server responds with a packet address to the inside global address of PC1, which is a 209.165.200.226. So it's going to get address back to that inside address, this one. Then the R2 receives the packet with the destination address 209.165.200.226. The R2 checks the NAT table and finds an entry for this mapping. R2 uses this information and translate the inside global address 209.165.200.226 to inside local address, which is going to be the 192.168.10.10, and the packet is forwarded towards the PC1. So what happened here, if I describe in plain simple English, what happened is that this device want to communicate outside of its network. And this device is trying to do is to communicate to this web server in the internet or in a different network. However, this device cannot see this server. So what it needs is a NAT, a network address translation. So what the network address translation is doing is that it is matching the IP address of the internal device to an external device is trying to communicate, so that it can be used for communication between the external and the internal device. So that is the simplest way I look at how the NAT tables work. So basically you have a NAT table similar to like this. So you have a NAT table will have an inside local address, which is the address of the device that's trying to communicate to outside. You have an inside global address, so that is an internal global address, and then you're going to have an outside local address, and then you have an outside global address. And using that information in the NAT table, this PC is now able to reach the internet, even though its internal IP address is not globally routable, because it is all done through the NAT translation. So that's how I look at this 6-step process. So let's look at some terminologies associated with NAT. The NAT includes 4 types of addresses. You will hear the inside local address, inside global address, outside local address, and outside global address. So you will hear those 4 types when somebody is talking to you about NAT. So the NAT terminology is always applied from the perspective of the device with the translated address. So remember, the NAT terminology, so if you want to know how this terminology is being applied or used, it is always applied from the perspective of the device with the translated address. So that means the inside, whatever the device that getting translated inside the local network. So the inside address is the address of the device which is being translated by the network address translator, so the NAT. The outside address is the address of the destination device. In our previous example, the outside address going to be the address of the web server. The inside address going to be the address of the computer, the PC1 that is trying to communicate to that web server. The local address is any address that appeared on the inside portion of the network. So the local address is the address that is the inside portion of that NAT table. So the NAT side. While the global address is an address that is any address that appears on the outside portion of the network. So remember, if you go back in here, so the inside address is right here, the outside address is right here, and the other options that we have in here is the inside local address and the global address. So the local address is here, global address global address is outside, and then you have the inside local and the outside local. So you actually see all of that information appear on the NAT table. So remember those terms, and remember that the terminology is applied from the perspective of the device with the translated address. So that's very important. Inside local address. The address of the source as seen from the inside of the network is the inside local address. This is typically a private IPv4 address. The inside local address of PC1 in this example is the 192.168.10.10 because that is the local internal IP address of that PC. So that is the inside local address. The inside global addresses, this is the address of the source as seen from the outside network. The inside global address of PC1 in this example going to be 209.165.200.226. So this is the address of the source as seen from outside of the network. So if somebody looking from outside to the inside of the network, it doesn't see the 192.168.10.10. Instead, it sees the 209.165.200.226. Outside global address is the address of the destination as seen from the outside the network. So from outside the network, whatever the address that is seen as the destination, as address of the destination seen from the outside is what we call the outside network, which is outside of this. So the outside global address in this example for web server is 209.165.200.1, which is that one. The outside local address, however, is the address of the destination as seen from the inside of the network. So the outside local address is the address of the destination as seen from the inside of the network. So the PC1 sends traffic to the web server at IPv4 address of 209.165.200.1. So that would be the outside, the local address. While it is uncommon, this address could be different than the globally routable address of the destination. So remember that. Even though it is very uncommon to see that, this address could be different from the globally routable address of the destination address. So that now you can see those different addresses and how it's being used on the right hand side. So we have the inside local address in a graphical format. You see this here, and you have the outside local address when the data is going this way, and then you have the inside global and the outside global. When the data coming back, you have the outside global address, inside global address, outside local address, and the inside local address. So you can see that in a graphical format on the right hand side. Types of NAT. Static network address translation, or static NAT, uses a one-to-one mapping of local and global address configured by the network administrator that remain constant. So just like the term static, what it stands for in English, it is a statically assigned. That means an administrator manually assign the NAT in static NAT. Static NAT is useful for web servers or devices that must have a consistent address that is accessible from the internet, such as a company web server or a company email server, FTP server, etc. It is also useful for devices that must be accessible by authorized personnel when off-site, but not by general public on the internet. So because you don't want those IP addresses and information to change, for those resources that has to be accessed by someone remotely outside the network, you can create that static NAT entries. So on the right hand side, here's an example of that. You have an inside network with a server and several end devices connected to a switch. And you can have a static NAT translation assigned to this particular server so that it won't change its IP addresses and other configurations associated with that NAT translation by configuring it in the administrative sections of the router. So you can go into the NAT table and you can enter an entry so that the entry for this server will remain the same in the inside global address, with respect to that internal IP address of that server. Please note, the static NAT requires that enough public addresses are available to satisfy the total number of simultaneous user sessions. So if you are creating these kind of static NAT entries, you need to have enough public addresses available to satisfy the total number of simultaneous users in a session. So remember that. The other option is called the dynamic NAT. So that's another type of NAT. So in dynamic NAT, uses a pool of public addresses and assigns them to a first come first serve basis. So just like what it sounds like, it is dynamically assigned, method. So when an inside device requests access to an outside network, the dynamic NAT assigns an available public IPv4 address from a pool. The other addresses in the pool are still available for use, but it's going to assign dynamically as the request comes in. Please note, the dynamic NAT requires that enough public addresses are also be available to satisfy the total number of simultaneous user sessions. So just like the static NAT, the dynamic NAT also requires that enough public addresses are available for simultaneous use. So on the right hand side, you can see a situation where we have the dynamic NAT configured. Now in this case, the router will be dynamically assigning those NAT translations based on the request it gets from the inside network. Port address translation. Port address translation, also known as NAT overload, maps multiple private IPv4 addresses to a single public IPv4 address or a few addresses. So with PAT, when the NAT router receives a packet from the client, it uses the source port number to uniquely identify the specific NAT translation. PAT ensures that devices use a different TCP port number each session with a server on the internet. So in other words, if these two computers try to reach the exact same server through this one router, it still can use the same public IP address, but because they're coming from two different ports, the PAT gonna associate those ports so that both of these devices inside the network can access the same server at the same time. If you look at your home network, and your ISP provided router, it is actually running PAT instead of NAT. So you probably have like one or two publicly facing IP addresses. So most likely for most home users, it's going to be one publicly facing IP address. And then you are using the PAT, the port address translation method, for communicating with the outside world. So what is the key feature with the PAT is that with PAT, when the NAT router receives a packet from the client, it uses the source port to uniquely identify that NAT translation so that everybody can use multiple devices can use the same IP address, but associated different ports with it to communicate to the outside world. So that's the way I look at the NAT. And what actually NAT's doing is that the NAT is modifying the layer 3 headers, while the PAT is modifying both layer 3 and layer 4 headers. Next available port. PAT attempts to preserve the original source port. if the original source port is already used, PAT assigns the first available port number starting from the beginning of the appropriate port group. So it could be from 0 to 511, 512 to 1023, or 1024 to 65,535. So what PAT going to do is PAT attempts to preserve the original source port, but if the original source port is already used, then what's PAT gonna assign a available port number starting from the beginning of the appropriate port group. So if the original port is fall between in here, it's gonna find an appropriate port within here. If it is false in here, it's gonna find an appropriate port in here. So when there are no more ports available and there is more than one external address in the address pool, PAT moves to the next address to try to allocate the original source port. The process continues until there are no more available ports or external IPv4 addresses in the address pool. So in this example, we have the inside network with 3 end devices. We have a router with the PAT configured, and we have the outside internet. And if you look at the NAT table with overload, because NAT with overload is the same as PAT, remember, it's the same term, like a same concept. So NAT overload or the PAT is basically have that, inside global IP address and the inside local IP addresses. But however, what differ this from the typical NAT table is that these IP addresses have port numbers associated with it. Because remember, the PAT is modifying both the layer 3 and layer 4, as opposed to NAT only modifying the layer 3 headers, right? So layer 3 header is associated with just the IP address, and the layer 4 is associated with the port number, so the type of port that being used. So in PAT, we are modifying both the layer 3 IP address and the layer 4 port number. So remember that that is a difference between NAT and PAT. So in the next page, we are actually looking at some of the differences in a table. So on the right hand side, there is a summary of differences between NAT and PAT. So on NAT, 1-to-1 mapping between inside local and inside global addresses, while PAT, one inside global address can be mapped to many inside local addresses, because now we have port number association. NAT uses only IPv4 addresses in translation process, while the PAT uses IPv4 addresses and the TCP or UDP source port numbers in translation process. So it uses IP and the port. NAT uses a unique inside global address is required for each inside host accessing the outside network. So in the NAT, you need to have a unique inside global address for each inside host. But with PAT, a single unique inside global address can be shared by many inside hosts accessing the outside network. So PAT has more advantages than NAT. And remember, NAT only modifies the IPv4 addresses, while the PAT modifies both the IPv4 address and the port number. Hence, the NAT, as I mentioned before, only modify the layer 3 header, while the PAT modify both layer 3, which is the IP address, and the layer 4 headers, which is the port number. You should remember this like back of your hand, because this will show up on your exams and quizzes. Packets without a layer 4 segment. Some packets do not contain a layer 4 port number, such as ICMP version 4 messages. Each of these types of protocols is handled differently by PAT, because remember, PAT utilizes both layer 3 and layer 4, but not all packets contain layer 4 information, such as the port numbers, right? Such as the ICMPs. So for example, the ICMP version 4 query messages, echo request and echo replies include a query ID. ICMP version 4 uses the query ID to identify an echo request with its corresponding echo reply. Please note, other ICMP version 4 messages do not use the query ID. These messages and other protocols that do not use TCP or UDP port numbers vary and are beyond the scope of this curriculum. So keep that in mind, back of your mind. It is not part of this course, this lecture series for now, but in the future, I will cover this. The PAT uses both layer 3 and layer 4 modification. NAT do not. However, not all packets that you're going to send through the PAT will have layer 4, which is the port number, such as the ICMP version 4. But those are handled differently by the PAT, which we will not cover in this lecture. Okay, that's all you need to know for now for NAT versus PAT. So remember the layer 3, layer 2 differences. And also remember that PAT is what actually being used in most homes. So if you buy a router, if you get a router modem combination from your ISP, when you connect to the internet, when you are watching this video, for example, by connecting to youtube.com, you are basically using a PAT, not a NAT, even though we typically misuse the term NAT all the time. Most home routers, most home router modem combination devices use a type of PAT. So it is PAT. So that's what you need to understand. For now, don't worry about how ICMP version 4 packets are handled by the PAT, but it is beyond the scope of this class. So there's a packet tracer file called Investigate NAT Operations. If you have access to this file, please go ahead, download it and do it. If you do not, I will leave a copy in the sanuja.com website, and I will make sure to leave a link in the description so you can go and click and download it and do it. NAT Advantages and Disadvantages. So let's look at the advantages of NAT. NAT provides many benefits. They include NAT conserve the legally registered addressing scheme by allowing the privatization of intranets. So what basically it is doing is that, remember the IPv4 address exhaustion issue? So that is being addressed by NAT. So the NAT is basically conserving the legally registered addressing scheme by allowing the privatization of the intranet. So the internal networks of any LAN network is now separated from globally routable IP addresses as a result of use of NAT. NAT also conserves the address through application port level multiplexing. NAT increases the flexibility of connections to the public network. NAT provides consistency for internal network addressing schemes. So that means that you can have a specific addressing schemes associated with your organization you can use, because you are behind a NAT. You can use whatever the addressing scheme you like. You don't have to worry about, whether it's globally routable or not. Like, for example, you may want to use 192.168.10 dot something like that, or you 192.168.20 dot something, or for something else within your network, and 192.168.30 dot something for something other than those two. So on and so forth. Like, you can customize the any way you like, for your internal network, the addresses, because they are not like a globally routable IP addresses. They are just within your organization. NAT also allows the existing private IPv4 address scheme to remain while allowing for easy change to a new public addressing scheme. NAT hides the IPv4 addresses of users and other devices. So NAT theoretically, like, it's not a very good way to for security, but it is better than expose IP addresses to the outside world. So the NAT basically hides the internal IP addresses from the outside world. But remember, NAT is not a firewall though, so it's not a security feature, but it kind of provides a type of security where it's kind of hides the internal IP address from the outside world. But remember, it's not a security feature though. Okay. So what are the disadvantages of NAT? So the drawbacks or disadvantages include NAT increases forwarding delays, because remember, every data packet that goes through the PAT or NAT has to be translated every single time it goes out, as well as every single time the packet comes back in, right? So if you want to access a web server from inside, your initial transaction has to be translated through the PAT or NAT. And when the web server sends the information back to you, that packets also has to be translated by either NAT or PAT. So that gonna create a forwarding delays. It also can create end-to-end addressing loss. So it causes the loss of the end-to-end addressing. So the addressing is not consistent. So your device is not directly addressing the server outside your network. It's actually there's a type of a man in the middle situation, right? Basically a NAT is basically acting as a translator between the outside world server and you. So that's what it means by the end-to-end addressing is lost. The end-to-end IPv4 traceability is also lost. So there are situations where you need to trace the IP for troubleshooting as well as for other reasons, and that will be lost at the NAT. NAT complicates the use of tunneling protocols such as IPsec. So if you have IPsec tunnels that you need to create, like a VPN tunnels, NAT will create complications, which we will cover later sometime. So I will go over like IPsec and VPNs and how NAT can complicate it, and how we go about resolving that NAT complication with respect to IPsec. I will cover that in a later lecture. NAT also have an issue with services that requires the initiation of TCP connections from outside network or stateless protocols such as those using UDP, because those can be disrupted as a result of NAT. So the services that require the initiation of a TCP connection from the outside network or the stateless protocols such as UDP could have a disruption because of the NAT translation. So while we have overcome some of these issues, it's not completely eliminated. That's what you need to understand. So for your exams and quizzes, you should know all of these items listed here as the disadvantages for using a NAT. Static NAT. Static NAT scenario. Static NAT is a one-to-one mapping between an inside address and an outside address. Static NAT allows external devices to initiate connections to internal devices using statically assigned public addresses. For instance, an internal web server may be mapped to a specific inside global address so that it is accessible from outside network. So if you have a web server internally inside your network, and if you want clients outside accessing that website, you have to assign a static NAT so that every single time that this data passes through your router, that it is always the same. So same port, same IP address, same everything, so that public system can have access to your web server. So that is an example of a static NAT scenario. Configure static NAT. So there are two basic tasks when configuring static NAT translations. In Cisco routers, the step one is to create a mapping between the inside local address and the inside global address using the command IP NAT inside source static command. So that's the command you need to use, IP NAT inside source static, right here. And then you're going to enter the IP address and the associated information. And the step two is the interface participating in the translations are configured as inside or outside relative to the NAT with the IP NAT inside command and IP NAT outside commands. And you can see that being entered right here. So this is how you actually create a static NAT on your Cisco routers. Again, I will go through these kind of examples in a live lab demonstration later and post to my YouTube channel as a separate video. But for now, just know these commands: IP NAT inside source static, IP NAT inside, and IP NAT outside. Analyze static NAT. The static NAT translation process between the client and the web server can be summarized with these 5 steps. So the client sends a packet to the web server. So that's the first thing gonna happen. So the client send a packet to the web server asking, hey, I want to access this website. The R2 receives the packet from the client and in its NAT outside interface and check its NAT table. So the R2 get the message and check its NAT table. R2 translates the inside global address of the inside local address and forward the packet towards the web server. So it's going to get forwarded to the web server based on the NAT table information. The web server receives the packet and responds to the client using its inside local address. Then the R2 receives the packet from the web server on its NAT inside interface with the source address of the inside local address of the web server, and it also translates the source address to the inside global address. So these are the 2 things that at the very end that this thing gonna do. The NAT that is located in the router. So how do you verify static NAT? So to verify the NAT operation, you can issue the command show IP NAT translations. And this command shows the active NAT translations. Because the example is a static NAT configuration, the translation is always present in the NAT table regardless of any active communication. So you don't need to have traffic pass through to generate this data because it is a static NAT configuration. So if the command is used during an active session, the output also indicates the address of the outside device as well. In this case, it is a static NAT, and you can actually see that being mapped right here with the show IP NAT translations command. Another useful command is to use show IP NAT statistics. It displays information about the total number of active translations, NAT configuration parameters, the number of addresses in the pool, and the number of addresses that have been allocated. To verify that the NAT translation is working, it is best to clear the statistics from any port translation using clear IP's NAT statistics command before trying out the show IP NAT statistics, so that you will have a better idea about whether whatever the changes that you made is actually working. So if you run the show IP NAT statistics, it'll show you how many hits and the misses and some data associated with that, but you can run the clear IP NAT statistics to clear that information and see if it is working afterward. So there's a packet tracer file called configure static NAT. If you have access to that file, please go ahead and do it. If you do not, I will post a copy of this file to my sanuja.com website once I find one, and so you can download and go ahead and do them. Again, I will do these packet tracer options like the module examples and activities on separate videos and post to my YouTube channel later sometimes. Dynamic NAT. Dynamic NAT scenario. Dynamic NAT automatically maps inside local addresses to inside global addresses. Dynamic NAT uses a pool of inside global addresses. The pool of inside global addresses is available to any device on the inside network on a first come first serve basis. So basically, as the term suggests, dynamic, it's automatically assigning IP addresses to inside devices that is trying to reach the outside networks by using a pool of available global IP addresses. And how it is doing that is first come first serve basis. So whichever the inside device first requests it, it gets the an IP address assigned from that pool from the dynamic NAT scenario, in the dynamic NAT situation, right? So the thing about this is that if all the addresses in the pool are in use, a device must wait for an available IP address before it can access the outside network. So because it is dynamically assigned, we are using the first come first serve basis to assign those internal global addresses. If the internal or inside global address pool get exhausted, then the next inside device trying to reach the outside network has to wait for an available address so it can get assigned a internal global IP address so that it can reach the outside network. So just like the name suggests, dynamic NAT, in this scenario, the NAT is automatically mapping the inside local addresses to inside global addresses. So on the right hand side, we have a router R2 that is using the dynamic NAT. So when one of these devices try to reach the server outside of its network, it is going to use the automatically assigning the IP addresses method to assign an IP address to these end devices using the pool of global IP addresses in the NAT. And then that device can reach the outside network using that mapping. So that's how the dynamic NAT works. So on a Cisco device, you can configure dynamic NAT by following 5 steps. So the first thing we need to do is to define a pool of addresses that will be used for translation using IP NAT pool command. So the command is IP NAT pool. So that's the command you should remember. And next step, what we're going to do is to configure a standard access control list to identify or permit, in this case, only those addresses that are to be translated. Then, just like any other ACL, what we're going to do is we're going to bind the ACL to the pool using the IP NAT inside source list command. So on the bottom of your screen, you see these 3 steps done on this Cisco router. So we have the IP NAT pool. So that's the command we use to define the pool of addresses for the NAT translation. And we have named the pool as NAT-pool1. So this is for identification of that pool. So then we have assigned the IP address pool of 192.168.200.226 to 192.165.200.240. So that's a range of IP addresses that we're going to assign to this NAT pool with the subnet mask associated with that. Then we have created the access list here using the access-list command with permitting that those networks. And then we have bind that access list to this NAT pool. So if you don't remember how the access list works and how you can configure them, you can watch my previous lecture on access list. But in this scenario, we are using that knowledge to assign that access list, creating an access list and assigning that access list to this NAT pool. So those are the first 3 steps you need to take in the 5-step process of creating a dynamic NAT on a Cisco router. So the next thing what we're going to do is to identify which interfaces are inside. So once you have created the NAT pool and have assigned it to the the access list, next we are using the interface commands to identify inside interfaces, and then identify also the outside interfaces. So in this example, we have identified the serial 010 as the inside interface and the serial 011 as our outside interface. Hence, what we're going to do is we're going to go to interface configuration for serial 0101 with the interface serial 101 command. And we're going to issue the command IP NAT inside for that. And then we're going to go into the interface configuration for serial 011. And then we're going to issue the IP NAT outside command. So that what these commands going to do is going to make the serial 010 the inside interface, and then the serial 011, the outside interface, which is required for our NAT operations. So that would actually create the dynamic NAT on a Cisco router. Analyze dynamic NAT inside to outside. The dynamic NAT translation process includes the following steps. So it includes several steps. This is 3 of them, and we will go into the next slide to discuss the other steps associated with this. So in this scenario on the right hand side, the same network diagram that we viewed a few slides ago, on the right hand side, you have that R2 router that is translating the NAT request that coming from the inside network to the outside network, right? So in this situation, the PC1 and PC2 send packets requesting a connection to the server. The server is located in the outside of this network, right? So the next thing what's going to happen is R2 receives the first packet from PC1, checks the ACL to determine if the packet should be translated, select an available global address, and creates a translation entry in the NAT table. So what happened is, when the PC1 requests the access to the server, the first thing this router gonna do, it's gonna check, hey, is this need to be translated to the outside, or is it just an internal routing thing? So if it is external, in this case it is, because it's trying to access this server, what it's gonna do is it's gonna check the ACL to determine if the packet, how the packet should be translated, and then select an available global address from its pool, and then assign it to that request, and then add that information to its NAT table. Then what's going to happen is R2 replaces the inside local source address of PC1, which is 192.168.10.10, with the translated global IP address of 209.165.200.226 and forward that packet. So before forwarding that packet, what's next going to happen after the NAT table entry has been created is to convert the inside IP address of that PC to the inside global IP address that assigned by the NAT process. The same process occurs for the packet from PC2 using the translated address of 209.165.200.227, which is shown on the right hand side. So we have a NAT pool, and here's a inside local IP address. So for the PC1, which is 209.165.200.226 is the global that assigned to the local one here. And for the PC2, the NAT has assigned 209.165.200.227 to that PC2 internal IP address. So you can see that on the NAT pool. So this is what's happening right here. So this PC1 and PC2 request the connection to the server outside. It goes to this R2 router, and the R2 router checks the ACL to determine if the packet should be translated. And if it is needed to be translated, then it's going to select from a global IP address, internal global IP address, and assign them accordingly to this request, and add that to its IPv4 NAT pool table. So that's the first 3 steps going to happen in the dynamic NAT. And the next thing is the server receives the packet from the PC1. So after that, the table has been created, after the IPs has been assigned the internal global IP address, the server receives the packet from the PC1 and respond using the destination address of 209.165.200.226, because that is the one that been assigned during the NAT process on this R2. The server receives the packet from PC2. It responds to the request using the destination address of 209.165.200, but this time it is 227 because it is the PC2 that is requesting the connection. So basically, when the server receives the information from this one, it goes with this IP address. When the server receives from PC2, it goes with this IP address. Why? Because in the previous process, we have created this NAT pool and assigned these NATs associated with those PC1 and PC2 internal IP addresses. In the next step, the fifth step, what's going to happen when the R2 receives the packet with the destination address of 209.165.200.226. So this is going to receive that information back from the server. It performs a NAT table lookup and translate the address back to the inside local address and forward the packet towards the PC1. Remember, on our previous steps here, we have created the NAT table entry right here. So when the R2 receives the packet from the PC1 and PC2, it check the ACL, determine if the packet should be translated. And what's going to happen is it's going to assign an internal global IP address, and it also creates a translation entry in the NAT table, right? Now that entry is now being used here is to again translate it back to the inside local address and forward the packet towards the PC1 in this case, because the PC1 requested it. So when the R2 received the packet with the destination address of 209.165.200.227, it performs a NAT table lookup and translates the address back to the inside local address of 192.168.11.10 and forward the packet towards the PC2, because in this case 226 is associated with PC1 in the NAT table, and the IP address ending 227 associated with PC2 on the NAT table, so it gets translated to the internal IP address of that for PC2. So those are the steps that gonna take for the translation. And what's gonna happen next is the PC1 and PC2 receive the packets and continue the conversation back and forth between the external server and the internal device. So the router performs steps 2 to 5 for each packet. So each time these internal devices try to communicate outside and system, it goes through these 5 steps, this and these 2 steps every single time. So it's try to communicate. So again, to summarize this, because this is a very important concept, PC1 and PC2 send packets requesting to the outside world. The R2 dynamic NAT gonna assign random IP address out of its dynamic NAT pool of IP addresses if it is available based on the ACL. So then it will add those entries to the NAT table and then forward the information to the outside server. And when the outside server come back and reply back to the R2, it's going to use those inside global IP addresses assigned by the R2 to communicate back to the R2, but then R2 going to translate it back to these PC1 and PC2 internal IP addresses based on the NAT pool entries that it has created in step 2. And then the process repeats over and over and over as it starts communicating back and forth, between the internal devices and the external source. So it's gonna go through the process of 1, 2, 3, 4, 5 over and over and over until the communication is terminated. So that's the process of dynamic NAT outside to inside. So how do you verify dynamic NAT? So on a Cisco device, the output of the show IP NAT translations, so the command is show IP NAT translations, can be used to display all static translations that have been configured and any dynamic translations that have been created by traffic. So if you run the command show IP NAT translations, it will show you all the translations here. This is not only a useful command for you to verify your NAT, but also may be used by your instructor. Like in my instructor have used show IP NAT translations to verify your lab exams is done properly. So this is something that very easy way to check if the student have done what they're supposed to do. So this is a good command that you should remember. Adding the verbose keyword display additional information about each translation, including how long the entry was created and used. So if you use show IP NAT translation and you add the additional command verbose right here, it will give you some additional information related to that dynamic NAT. By default, translation entries time out after 24 hours. Unless the timers have been reconfigured with the IP NAT translation timeout command. So remember this command as well, IP NAT translation timeout, and then you can put the timeout variable, in this case in seconds, right here. To clear dynamic entries before the timeout has expired, you can use the clear IP NAT translation command. So that is clear IP NAT translation command. And the IP NAT translation timeout is entered in the global configuration mode, while the clear IP NAT translation can be entered in the privilege executive mode. And on here, you can see that command entered, clear IP NAT translation with a star here, and the show IP NAT translation will show the IP addresses. And the bottom of your screen, you have a table that actually describes some of these commands and its options. And if you have ever researched a Cisco manual, you may be familiar with this type of notations that they use. So you should be familiar with these type of notations, even though I haven't gone through them a lot. So in here, it shows a command clear IP NAT translation with a star, and it gives you a description. It clears all dynamic address translation entries from the NAT translation table. Typically, the star command will mean that it will clear everything associated with that command behind it. The clear IP NAT translation inside with these type of, how it's written here, those are like variables that you can change. So this clears a simple dynamic translation entry containing an inside translation or both inside and outside translations. So in here, these are things, the variables that you can enter. The outside is a keyword. These are all keywords. So this is a key command. So this is a full command that needs keywords, and this is a keyword, and these are like the variables that you can enter. The next one, it clears an external dynamic translation entry. It is clear IP NAT translation. Then you can enter the protocol here, and then the inside is a keyword, and these are the options, and then the outside is a keyword, and again options right here. If you are reading again those Cisco manuals, they are usually written like this way, and I will go maybe I will do a quick video on how to read Cisco manuals later sometime, but for now just remember these commands exist. The show IP NAT statistics command display information about the total number of active translations, NAT configuration parameters, the number of addresses in the pool, and how many of the addresses have been allocated. So remember, in the dynamic NAT, we have created a pool of IP addresses that can be automatically assigned. So the show IP NAT statistics will show how many of those IP addresses are in use, and associated statistics related to that, such as the NAT configuration parameters. So if you run show IP NAT statistics, this is the screen that you're going to see on your Cisco routers if you have the dynamic NAT configured. And right here it says the name of the NAT pool. So remember from our previous example, we used the NAT-pool1 as our name of the NAT pool, and it shows the configuration options right here, the pool range, the net mask, and the how many addresses are now allocated. So in this example, we have 15 addresses allocated, 2 addresses allocated out of 15. That is 13% usage of this entire pool, because pool have 15. So if you divide 2 by 15, multiply by 100, that will give you 13%. So that's 13% of your pool have been used, and it's clearly nicely displayed up here. So for that, you use this command. The show running -config command with the piping character, this line character, with the NAT cal interface or pool commands with the associated required value can be used to also display some NAT information. In this example, we have the show running -config, and we are piping or filtering whatever the information that includes NAT in it. And in here, we have the display of that NAT information on these two lines. So you can use the show running dash config pipe include NAT, include cal, include interface, or exclude NAT. So you will see everything except the NAT. So I have gone through what this character do. It's like it's called a piping character. It basically filter out certain things, and as you go through these courses, you'll get to know how to use those. So this is basically limiting the or filtering out the information so it's easy for you to read. There's a packet tracer file called configure dynamic NAT. I will try to find a copy of that packet tracer file and post to my sanuja.com website. If you do have access to Cisco NetAcad, or you have access to this packet tracer file through your academic institution, please go back to those institutions and download those and then do them as you go through these lectures. PAT. Configure PAT to use a single IP address. To configure PAT to use a single IPv4 address, add the keyword overload to the IP NAT inside source command. Remember from my previous lectures and slides, I mentioned PAT is also known as NAT overload, right? PAT is also known as NAT overload. So this is why you can simply use the overload command to the IP NAT inside source command in order to create your NAT PAT. In the example below on the bottom of your screen, all hosts from network 192.168.0.0/16 matching ACL1 that send traffic through router R2 to the internet will be translated to the IP address 192.165.200.225, which is IPv4 address of interface S011. The traffic flows will be identified by port number in the NAT table because the overload keyword is configured. See, in right here, you can see that the overload keyword is entered along with the NAT inside source list interface serial 010. Therefore, what's going to happen is the traffic flow will be identified by the port in the NAT table because of that keyword command, right? That's a key. It's a keyword that can be used in this command. So what happening here is the NAT overload, which is also known as PAT, right? Remember that. Configure PAT to use an address pool. An ISP may allocate more than one public IPv4 address to an organization. In this scenario, the organization can configure PAT to use a pool of IPv4 public addresses for translation. Remember, I have mentioned previously that most of the home routers and modem combinations, as well as small business routers, even large networks, sometimes the ISP provided devices actually using PAT. Even though we keep calling it NAT all the time, it's actually using PAT because you probably most likely have one or very limited number of outside internationally globally routable IP addresses outside. So what's going to happen is the PAT will be used for the IP address translation process, even though we often hear network engineers and technicians keep using NAT as a misnomer, right? So remember that. But however, your ISP may have provided to you more than one external IP address. For example, I am with Showcable Canada, and Showcable, because I have a higher tier internet service, so they have different tiers of internet. I have two globally routable public IP addresses. So I have two IPv4 global addresses assigned to my internet connection. So in that situation, a PAT can use a pool of IPv4 public addresses for translation. So to configure PAT for a dynamic NAT address pool in a Cisco router, you need to add the keyword overload to the IP NAT inside source command. So overload keyword will be added to the IP NAT inside source command in this scenario. So in this example, the NAT-pool2 is bound to an ACL to permit 192.168.0.0/16 to be translated. So these hosts can share an IPv4 address from pool because PAT is enabled with the keyword overload right here. So right here we have the IP NAT inside source list 1 pool, and NAT-pool2 is now associated with that access list 1, but now we have the overload command entered right here. As a result of that, these hosts now can share IPv4 addresses from the pool of PAT that is enabled via that keyword. So that's what's happening right here. So again, as I mentioned, PAT is what is commonly used today in most IPv4 associated ISP devices, whether home modems and routers or small business homes modem and routers. So they typically use the PAT. Because remember, PAT is the port address translation, and it has both layer 3 and layer 4 headers that gonna be modified in PAT as opposed to NAT, right? So that's why we use PAT, because it is more versatile and flexible. So let's analyze PAT. In this scenario, the server to PC. So on the right hand side, we have a router that is configured with PAT. It is a similar configuration, but we have 2 servers on the outside now. And based on that information here, let's see what's going to happen when it's trying to connect with the inside and outside networks. So the PC1 and PC2 send packet to server 1 and server 2. So the PC1 and PC2 are sending packets to both server 1 and server 2. Both servers are being now accessed by these 2 devices, trying to access right now. So what's going to happen next is the packet from PC1 reaches the router 2, this router where the PAT is happening first. So as a result, the R2 modifies the source IPv4 address to 209.165.200.225, which is the inside global address. The packet is then forwarded to the server 1. So the R2 get it, and it use the inside global address assignment to assign this global inside address to the PC1. The packet from PC2 next arrive at the R2. So the PAT changes the source IPv4 address of PC2 to the inside global address of 209.165.200.225. Notice the inside global address of these 2 are now the same. So the PC2 has the same source port number as the translation for the PC1, because these are the same. So the PAT increments the source port number until it is a unique value in its table. In this instance, it's going to be 445. So in this PAT scenario, unlike the previous example, what's going to happen is the inside global address for both PC1 and PC2 trying to reach these servers are the same. It's the same 209.165.200.225. However, the port number now going to be different in the inside global address for these 2 PCs. Hence, it can be used to identify traffic goods that's supposed to go to one PC from the other. In this case, 1444 port is used by the PC1, and 1445 port is used by the PC2, because what happened in PAT, it increments the source port number until it is unique value in its table, and as a result, now you can identify traffic that's supposed to go to the PC1 from traffic that's supposed to go to the PC2. And the NAT table in this scenario, in this PAT scenario, looks like this on the bottom of your screen. One thing you should notice, as I mentioned, because now we are using both the IP address and the port number, PAT has the ability to modify both layer 3 and layer 2. In other words, it can modify the IP address as well as the port number, and it is displayed clearly on the right hand side of your screen right here. So let's look at what happened in PAT when the PC to server traffic. So in this case, now we are going to look at PC to server traffic. So PC1 and PC2 send packets to server 1 and server 2. The packet from PC1 reaches the R2 first, just like before, and then the R2 modifies the source IPv4 address to 209.165.200.225, which is the inside global address. The packet is then forwarded to server 1. The packet from PC2 arrives at R2. PAT changes the source IPv4 address to PC2 to the inside global address of 209.165.200.225. Again, look, it's the same. So the PC2 has the same source number as the translator PC1. So the PAT increments the source port number until it is unique value in its table. In this instance is 445. So you can see that right here. So this is server to PC and this is PC to server. But notice it is the same process, but it's slightly different. Right, so notice that. So it's the same thing, right? Sorry. So this is server to PC and this is PC to server, but the process is very similar because it's using PAT. So next we're going to look at finally the server to PC. So in this case, server used the source port from the receive packet as the destination port and the source address as the destination address for the return traffic. R2 changes the destination IPv4 address of the packet from server 1 from 209.165.200.225 to the internal IP address of PC1, which is 192.168.10.10, and forward that packet to the PC1. R2 also changes the destination IP address of the packet from server 2 from 209.165.200.225 to the internal IP address of PC2, in this case 192.168.10.11, and modifies the destination port back to its original value of 1444. So the packet is then forwarded to PC2. So that's the basic operation, how exactly the PAT operation works when the inside network and outside network communicate with each other. So if you find this a lot of information that it's really hard to remember, please go back on this video and watch those few slides again, and you will understand exactly what is described here, because not only I have explained what's shown here on the right hand side, but you also have this diagram and the information shown in what's happening here. And remember, PAT can modify both layer 3 and layer 4, so it's a port number and the IP address, while the NAT cannot. NAT doesn't do that. So that's the difference between PAT and NAT, and that is why we use PAT a lot in home and small business use. So how do you verify PAT? The same commands used to verify static and dynamic NAT are used to verify PAT. The show IP NAT translations, remember that command, show IP NAT translation, can be used to display the translations from two different hosts to different web servers in the previous example. So notice that the two different inside hosts are allocated the same IPv4 address of 209.165.200.226 inside global address in that PAT example, but the source port numbers in the NAT table differentiate the two transactions. So right here we ran the show IP NAT translation. Hey, look at that. The inside global IP addresses are same for the both TCP requests, but however, the port number is different. In here 1444, the other one is 1445. So you have two different port numbers, hence differentiating one PC from the other PC on the inside network. The show IP NAT statistics, the same command we have used previously, can verifies that the NAT pool NAT-pool 2 has allocated a single address to both translations. How do you know that? Because allocated is showing here it's 1 because we only ran that PAT in this example. So also shown there are number and type of active translations, NAT configuration parameters, the number of addresses in the pool, and how many have been allocated. So just like before, the show IP NAT statistics show all of this data on your Cisco routers. If you run that command, then that's what you will see if you have the path configured in that router. There is a packet tracer file called configure path. If you have access to this packet tracer file, please go ahead and do it. If you do not, I will try to find a copy of this packet tracer file and post to my sanuj.com website, and then you can download from there and go ahead and do it. And again, I will go through these lab demonstration and packet tracer demonstration videos on a separate video clips and post it to my YouTube channel later sometime. NAT 64, which is basically for IPv6. NAT for IPv6. IPv6 was developed with the intention of making NAT for IPv4 with translation between public and private IPv4 address unnecessary. So basically, one of the primary reasons why we made IPv4 so that we don't need the NAT at the first place. However, IPv6 does include its own IPv6 private address space, unique local addresses, also known as ULAs. So even though IPv6 technically do not need a NAT translation to be used, because we have more than enough IPv6 addresses, you can have globally routable IPv6 addresses from your inside network all the way to the internet. IPv6 still have its own IPv6 private address space called unique local addresses, ULAs. IPv6 unique local addresses, also known as ULAs, are similar to that of the RFC 1918 private addresses in the IPv4, but have a different purpose. ULA addresses are meant for only local communication within a site. ULA addresses are not meant to provide additional IPv6 address space, nor to provide a level of security. So remember, in IPv4, you can use NAT for multiple reasons, including hiding your internal IPv4 addresses because it's doing NAT translations at the router, and also to conserve the IPv4 internationally globally routable addresses because we are running out, or we are exhausting those IPv4 addresses. But however, the ULA addresses in IPv6 are not meant for for doing that kind of security or to provide any additional IPv6 addresses. Instead, ULA addresses are meant for only local communication within a site. So remember, those are the key differences that you should know for your exams and quizzes. IPv6 does provide for protocol translation between IPv4 and IPv6, known as the NAT 64. So that's another thing that you should remember. So IPv6 does provide the protocol translation between IPv4 and IPv6 devices, so known as the NAT 64. NAT 64. NAT for IPv6 is used in a much different context than the NAT for IPv4. So everything you learn about the NAT in IPv4, most of the items that I have covered does not apply to NAT 64. So NAT for IPv4, also known as NAT in general, does not behave the same way as NAT 64, which is a part of IPv6. The varieties of NAT for IPv6 are used to transparently provide access between IPv6 only and IPv4 only networks, as shown on the right hand side in this figure right here. If you look at it, so it is not used as a form of private IPv6 to global IPv6 translation, but it is to make the communication between IPv4 only devices and IPv6 only devices possible. That's the primary purpose of NAT 64. NAT for IPv6 should not be used as a long-term method, but as a temporary mechanism to assist in mitigation from IPv4 to IPv6. So if you are creating a brand new network in 2022, for example, you should not be using NAT 64 at all. You should be just using IPv6 addresses. But this NAT 64 can be used for communication across IPv6 only and IPv4 only networks as a temporary measure during the transition period. In this class, for this module right now, I will not go into any more details on NAT 64 because that is not part of the curriculum for Cisco, this lecture series. So for now, this is all what you need to know about NAT 64. It is different from that of the IPv4 NAT. It is, not even close to what the functionalities why we use it. When you compare NAT 64 against the NAT, so they are completely two different things. And the primary reason why we use NAT today in 2022 is to make sure the transition between IPv6 only and the IPv4 only networks happen smoothly. So for now, that's all you need to remember for your exams and quizzes when it's come to the point NAT 64. So that would bring us to the end of this lecture. I'll introduce you to a few more packet tracer files, as well as go over what we have covered. So there are two packet tracer files called configure NAT for IPv4. So if you have access to these files through your Cisco NetAcad, please go ahead and do it. If you do not, I will try to find copies of those files and post to my sanuja.com website so you can download and do them. So here is a summary of what we have learned. So next few slides, I will go through the items that we have covered in this lecture. We learned that there are not enough public IPv4 addresses to assign a unique address to each device connected to the internet. That's where the term IPv4 address exhaustion came from. The primary use of the NAT, or network address translation, is to conserve public IPv4 addresses. In NAT terminology, the inside network is the set of networks that is subject to translation. The outside network refers to all other networks. We learned that the NAT terminology is always applied from the perspective of the device with the translated address. Remember, that's a very important concept. The NAT terminology is always applied from the perspective of the device with the translated address. So what is considered as the inside and what is considered as outside is from the perspective of the device that with the translated address. Inside address are the addresses of the device which is being translated by NAT. Outside addresses are the addresses of the destination device. Local address is any address that appears on the inside portion of the network, while the global address is any address that appears on the outside portion of the network. We also learned static NAT uses a one-to-one mapping of local and global addresses, while the dynamic NAT uses a pool of IP addresses, public IP addresses, and assign them on first come first serve basis. We learn about the concept of PAT, also known as port address translation. The PAT is also being called NAT overload because it maps multiple private IPv4 addresses to a single public IPv4 address for a few addresses or for a few addresses. So it can do either map multiple private IPv4 addresses to a single public IPv4 address or a handful of public IPv4 addresses. NAT increases forwarding delays because the translation of each IPv4 address within the packet headers take time. Remember, NAT is basically using the packet headers to do the translation, and it does increase the forwarding times. NAT complicates the use of tunneling protocols such as IPsec. Because NAT modifies values in the headers, causing some issues with the network configuration associated with IPsec. Remember, I did not cover IPsec and VPNs yet, but I will cover that in the future. Just for now, remember that NAT do complicate the VPN and IPsec configuration just for now, but in next few weeks I will explain how IPsec and VPN tunnels are created, and we will go into depth later. We learned the show IP NAT translations command display all statistical information related to translations that have been configured and any dynamic translation that have been created by traffic. We learn about how we can clear those entries in dynamic entries before timeout has expired. To do that, we're going to use the clear IP NAT translations command. We learn IPv6 was developed with the intention of making NAT or network address translation for IPv4 with the translation between public and private IPv4 addresses unnecessary. However, IPv6 unique local address, also known as ULA, are similar to that of RFC 1980 private address in the IPv4, but have a completely different purpose, which we didn't go into depth in this lecture. However, we mentioned that the IPv6 does provide for protocol translation between IPv4 and IPv6 known as NAT 64. So IPv6 still have a type of NAT which allow the communication between IPv4 and IPv6 networks, and those that particular system methodology is called NAT 64. That is the end of this module. If you like these type of lectures, please thumbs up this video and subscribe to my channel. As I mentioned before, I will go through lab demonstration within next few weeks so that you will have a comprehensive idea about NAT and PAT that we have covered. If you have any questions or concerns regarding any of the items that we have covered, please don't hesitate to reach out to me. Until next time, good luck with your exams and have a nice day.